Hello everyone. We're still in the section of the power indeterminate form, 1 to the infinity, 0 to 0, and infinity to the 0. We'll do this classic problem. What's the limit as x goes to positive infinity of 1 plus 1 over x to the x? All right, so let's plug it in. I get 1 plus 1 to the infinity, 1 over infinity. This part here is going to be 0, and so I get 1 to the infinity, which is indeterminate. All right, it's this first one right here. We're going to do the same thing we did in the last example. Whatever our power limit, our exponent limit is, I'm going to call it L, and then I'm going to look at ln of L so I can use this law of log. All right, so this is L. I'm going to look at ln of L. That's going to be the limit as x goes to positive infinity, log of 1 plus 1 over x to the x, limit as x goes to positive infinity, x log of 1 plus 1 over x. So this now is infinity times log of 1, so infinity times 0. Let me say one way I remember these is they're all the ones that turn into infinity times 0 when you apply log to it. So this one you get infinity times log of 1. This one you get 0 times log of 0, which is 0 times infinity. This one you get 0 times log of infinity. All right, now I'm going to bring x down because I want to transform it into a quotient so we could apply L'Hopital on it. So I'm going to get 1 over x. Now this one, I took the infinity down, so it's going to turn into 0 over 0. I'm going to get log of 1 plus 1 over, sorry, I forgot to differentiate. I'm applying L'Hopital, so I need to differentiate both. Here it's 1 over, so 1 over 1 plus x, and then derivative of the interior. So this here is a chain rule. Let me do it here. Chain rule. All right, with the interior is 1 over x, and that's why I have this term here. Now I'm going to be a bit cheeky. I need to take this derivative. I won't. I'll just write it as 1 over x prime because these will cancel. I don't even need to compute the derivative. You can, and you're going to get the right answer if you do, but I'm going to be a tiny bit lazy, which I like to do sometimes, and avoid computing something that anyways is on top and underneath and will cancel. So I end up with only this, which is 1 plus 1 plus 1 over infinity. And so that's 1 over 1 plus 0, which is 1. All right, because this is 0. Again, this is ln of L. And so if we want to have L, it's going to be e to the ln of L, which is e to the 1, which is e. All right, so this limit, which seems pretty simple, and in fact, this limit comes out of continuously compounded interest, and that's why you have this exponential, this e that comes into continuously compounded interest. In fact, that's the first time people thought of e is when thinking of banking, thinking of exponential, thinking of compounding interest as often as possible. All right, let's try a second limit. Let's try the limit as x goes to 0 plus of sine of x tan of x. If I plug it in, I'll get sine of 0, so 0. Tan of 0 is 0 as well. I get 0 over 0. Is it in my list? Yep. So it's indeterminate. So this is going to be L. I'm going to apply log to it. I'm going to get log of sine of x tan of x. The tan is going to come out, jump out of the log prison. I'm going to get sine. That's going to be 0 times infinity. And I'm going to bring the tangent down. It's going to be 1 over tan, which is cotan. So let me write it as cotan. That way it's going to be easier to take derivatives. All right, so I get sine log of 0, which is infinity, cotan of 0, which is infinity. So I have infinity over infinity. Now I'm going to take derivative. All right, I want you to try to remember what's the derivative of cotan. So derivative of tan is secant squared. Derivative of cotan, it's almost cosecant squared of x. You just add an extra minus. So every time you add a co, you put co's everywhere, and then you have an extra minus. So this one is minus cosecant squared of x. And then derivative of ln of sine, it's 1 over sine times the derivative of sine. Again, this one, chain rule. All right, so I get the limit as x goes to 0 plus. I get cosine of x over sine of x over minus cosecant. Cosecant is 1 over sine, so 1 over sine squared. Now, so much is going on. Let's try to simplify this. One of these signs will, let's bring those signs up, and so I'm going to get minus cos of x sine squared of x, and then I had one sine right here. This one's going to come down. So these flip to the top because I have a 1 over, and the other one flips to the bottom. And so I have limit as x goes to 0 plus minus cos of x sine of x. I get minus 1 times 0. I get 0. As usual, this is ln of L. Very tempting once you get a number to stop. Don't do it. You're missing out on easy points. All you have to do is to remember to do it and you'll get them. All right, so e to the ln of L, that's going to give you L. And so L is 1, not 0. All right, let's stop here. There's one final example, so I'll do one more video, I'll do one more example, and then I'll recap the method for these exponent forms. All right, so one more video in this chapter, and then we'll be done with L'Hopital.